Good afternoon to all students in physics online lectures. Now we are to start fourth chapter, that is the laws of motion. In laws of motion, what are the different types of motion? What do you mean by kinematical equations and what are they? There are three kinematical equations. Now the Newton's laws of motion apply to most bodies we can come across in daily life. Then acceleration is directly proportional to the force for fixed mass of an object. In this chapter, we see Newton's laws of motion. There are three types of motion: linear motion, circular motion, parabolic motion. Then Newton's the laws of motion: first law, second law, third law. Then importance of Newton's first law of motion, importance of Newton's second law of motion, importance of Newton's third law of motion, and then inertial, non-inertial frame of reference and types of forces. Now we start. First one, laws of motion. Introduction. If an object continuously changes its position, it is said to be in motion. Mechanics is a branch of physics that deals with motion. There are basically two types of mechanics: statics and kinetics. In statics, where we deal with objects at rest or in equilibrium under the action of balance force. In kinetics, which deals with actual motion. Kinetics can be further divided into two branches: kinematics and dynamics. In kinematics, we describe various motions without discussing their cause. Various parameters discussed in kinematics are distance, displacement, speed, velocity, and acceleration are the example of kinematics. And what are the dynamics? Dynamics will describe the motion along with its cause, which is the force or its torque. Parameters discussed in dynamic, that is the example of momentum, force, energy, power, etc. in addition to those in kinematics. There are two types of mechanics is the branch of physics that deals with motion. There are two types of motions. First one, statics, two branches, statics and kinetics. And in kinetics, there are again two branches, that is the kinematics and dynamics. See, this one is the example of kinematics and dynamics, where force is equal to mass into acceleration, force, mass into acceleration. Force and acceleration are the examples of kinematics and dynamics. Next one. There are three types of motion: linear motion, circular motion, and parabolic motion. First one, what is the linear motion? See here. Initial velocity may be 0 or non-zero in linear motion. If initial velocity is 0, starting from rest, acceleration in any direction will be result into the linear motion. If initial velocity is not 0, the acceleration must be in line with the initial velocity along the same and opposite direction to that of initial velocity for the resultant motion to be linear. कोणकोणते मोशन्स, कोणकोणते टाइप्स लिनियर मोशन असू शकतात? फर्स्ट वन, इनिशियल वेलोसिटी मे बी 0 or non-zero, also called as a linear motion. Second one, if the initial velocity is 0, starting from the rest, acceleration in any direction will result into the linear motion. This is the examples of rectilinear or linear motion. See here, apple falling from the tree, pushing a box, and this one is the examples of linear motion. Next one, circular motion. If initial velocity is not 0 and acceleration is brought perpendicular to the velocity, the resultant motion will be circular. This one is called as the circular motion. In last lecture, in last chapter, we already said what are the circular motion, what are the uniform circular motion. If initial velocity is not 0 and acceleration is thrown out perpendicular to the velocity, the resultant motion will be circular. This one is the example of circular motion. Next one. Suppose initial velocity is next one, circular motion. If the initial velocity, if the acceleration is constant and initial velocity is not in a line with acceleration, the motion is parabolic. Trajectory or a projectile motion. In last chapter, we already seen what is the projectile or what are the projectile motion. See which is the example of projectile motion. If acceleration is constant and the initial velocity is not in a line with the acceleration, the motion is parabolic, and trajectory or the parabolic motion. This is the example of projectile motion. Projectile motion is also called as parabolic motion. Next important point is what are the Newton's laws of motion. First law, object at rest remains at rest and object in motion remains in motion in a straight line unless acted upon by an unbalanced force. जोपर्यंत एखाद्या बॉडीवर एखाद्या ऑब्जेक्टवर आपण फोर्स अप्लाइड करत नाही तोपर्यंत ती बॉडी मोशन मध्ये और रेस्ट मध्ये येत नाही. दॅट इज कॉल्ड एज द फर्स्ट लॉ ऑफ न्यूटन्स लॉ ऑफ मोशन. Object at rest remain as rest. Object in motion remains in motion in a straight line unless acted upon by an external force or unbalanced force. This is the first law of Newton's motion. See here. This is the first law. Second law, force equals mass times in acceleration. That is, force is equal to mass into acceleration. See. And third law, for every action, there is an equal and opposite reaction. This one is the third law of Newton's. Next one. Importance of Newton's first law of motion. Now, what is the first law of motion? That is, object at rest remain at rest, object in motion remain in motion in a straight line unless acted upon by an unbalanced or external force. This is called as the first law. And then what are the importance of Newton's first law of motion? See, first point, it shows an equivalence between state of rest and the state of uniform motion along a straight line, as both need a net unbalanced force to the change the state. And both these are referred to as the state of motion. This distinction between the state of rest and uniform motion is in choice of frame of reference. Next one, it defines the force as a physical quantity, that is an entity that brings about a change in the state of motion of a body. That is, force is sometimes something that initiates a motion or it controls a motion. Second law gives the quantitative understanding of its mathematical expressions. And third point, it defines inertia. What is the meaning of inertia? Inertia is nothing but mass. Inertia as a fundamental property of every physical object by which the object resists any change in its state of motion. First of all, what is the inertia? Inertia is the mass. Greater the mass, greater the inertia. And that is, inertia is a fundamental property of every physical object by which the object resists any change in its state of motion. Inertia is measured as the mass of the object. More specifically, it is called as the initial mass, and which is the ratio of net force your corresponding acceleration. That is, force is equal to mass into acceleration. Extra, that is the larger inertia, larger force applied to the body. Next one, importance of second law of motion. What is the Newton's second law of motion? Second law of motion is nothing but force equals mass times acceleration. That is, force is the rate of change of linear momentum. That is the second law of motion. That is, the rate of change of linear momentum of a rigid body is directly proportional to the applied force and takes place the direction of applied force. That is, force is equal to mass into acceleration. See here, more the force, more will be the acceleration. It gives the mathematical formulation for the quantitative measure of force as the rate of change of linear momentum. Second point, it defines momentum. That is, P is equal to mass into velocity, where P is the linear momentum, mass into velocity instead of velocity as the fundamental quantity related to the motion. Then what is the change by the force is the momentum, not necessarily the velocity. This is the second importance of the Newton's second law of motion. And next one, Aristotle's fallacy is overcome by considering the resultant unbalanced force. This is the reduced syllabus for what is the exact fallacy is overcome by the considering the resultant unbalanced force. That is state that an external force is required. Which one is the fallacy? State that an external force is required to keep a body in uniform motion. That is, force is equal to mass into acceleration. The more the force and more the acceleration. Next one, importance of Newton's third law of motion. What is the Newton's third law of motion? Where every action there is equal and opposite reaction. This one is the Newton's third law of motion. And what are the importance of Newton's third law of motion? It defines the action and reaction as a pair of equal and opposite forces acting along the same line. Action and reaction forces are always on different objects. Every action has equal and opposite reaction. This one is the examples of the Newton's third law of motion. There are 2 points, which is the importance of Newton's third law of motion. First one, it defines the action and reaction as pair of equal and opposite forces acting along the same line, and action-reaction forces are always different on different objects. Next point is inertial and non-inertial frame of reference. Now, see here. What is the inertial and non-inertial frame of reference? First one, consider yourself standing on a railway platform or a bus stand and you see a train or bus moving. You are standing a railway platform or a bus stand and you see the train or bus moving. Just consider it. According to you, that train or bus is moving or in motion. As per experience, the passengers in the train or bus, they are at rest, but you are moving in backward direction. Just consider that the train or bus is moving, that is in motion. As per experience, the passengers in a train or bus, they are at rest. You are moving. You like that in backward direction. Hence, motion itself is a relative concept. That is called as the inertial or non-inertial frame of reference. You to know or describe the motion, you need to describe or define some reference. Such reference is called as the frame of reference. In the example discussed above, if you consider a platform as a reference, then the passengers and the trains are moving. However, if the train is considered as a reference, you and platform, etc. are moving. Okay. Inertial and non-inertial frame. When a brakes is applied, another example of inertial and non-inertial frames, when the brakes are applied to the bus undergoes a negative acceleration. At this moment, it becomes a non-inertial frame of reference. A non-inertial frame reference is a reference in which the laws of inertia does not hold. That is the second law of motion. It does not obey. That is the non-inertial frame of reference. That is in short, inertial, in which the Newton's second law is obeyed. First law, and in non-inertial frame of reference, the laws of inertia does not hold, does not obey. There is a main basic difference of inertial frame and non-inertial frame. A frame of reference either at rest or moving with a uniform velocity, zero acceleration is known as inertial frame. Is a frame of reference which is either having a uniform linear acceleration or being rotated with uniform speed. Inertial frame of reference are those references in which the Newton's laws are valid, and non-inertial frame of reference are the reference in which Newton's laws are invalid, in which non-inertial frame of reference Newton's laws does not obey. In inertial frame of reference, zero force corresponding to the zero acceleration. Here, non-inertial references, non-inertial force, zero force does not correspond to zero acceleration. This example of inertial frame, a train moving with a uniform velocity is an inertial frame, and a freely falling elevator may be considered as a non-inertial frame. In non-inertial frame, we are in at rest position, but just feeling like we are in motion. That is, Newton's laws does not obey. That is called as the non-inertial frame. In short, inertial frame where the Newton's laws are obeyed, but in non-inertial frame, Newton's laws not obeyed. See, example of inertial and non-inertial frame. Here a car is moving with an acceleration a to the right. A pendulum is from the roots of the car. The inertial frame bob is moving with an acceleration. And the passenger of the car seat, both hanging with at an angle to the vertical. Here the car is moving on a road is in a non-inertial frame of reference. See, observer is there in non-inertial frame of reference. And here I can see that the boy is going to the on that path. This is the examples of inertial and non-inertial frame of reference. Next point is that types of force. See, all the forces in nature are classified into the following four interactions that are seen as a terms as a fundamental forces. These are the four fundamental forces. First one, gravitational force. Second one, electromagnetic force. Third one, strong nuclear force. And last one, weak nuclear force. Now, these are the classified as the fundamental forces, which is the fundamental forces, that is the gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. First one, say gravitational force. It is the attractive force between 2 point masses separated by a distance. That is, the magnitude of gravitational force between point masses m1 and m2 is the separated by a distance r is given by F is equal to G m1 m2 upon r square. That is, F is directly proportional to product of their masses and inversely proportional to the square of distance between them. That is the Newton's law of gravitation. And where capital G is the constant of gravitation called as universal gravitation constant, and that value is 6.67 into 10 raised to minus 11 SI unit between 2 point masses of particles separated by a given distance. This is the biggest force having infinite range. This force is always attractive. Attraction, repulsion, there is not a repulsion. This force is only attractive force. The force of attractive force between 2 points of masses is directly proportional to product of their masses and inversely proportional to the square of distance between them is called as the Newton's law of gravitation, where G is the constant, Newton's gravitational constant, which value is 6.67 into 10 raised to minus 11, which is the weakest force. This force is always attractive. Structure of universe is governed by this force. Now, see here, gravitational force exerted by the earth on us, which can call us our weight W. Therefore, W is equal to G m upon r square. M small m आपण बाजूला काढल्यानंतर gm upon r square is equal to mg, where m and r represent respectively mass and radius of the earth. Distance between ourselves and the earth is taken as the radius of the earth when we are on the surface of the earth, because our size is negligible as compared to the radius of the earth, and where the radius of the earth is nothing but 6.4 into 10 raised to 6 meter. Substituting this value, we get 9.8 meter per second square is the small g, is the gravitational acceleration or acceleration due to gravity, that is gravitational field intensity. We feel this force only due to the normal reaction from the surface of our contact with the earth. This is called as the gravitational force. This is the one of the fundamental force, that is the gravitational force. Next. Next type is electromagnetic force. It is an attractive or repulsive force between electrically charged particles. That is, electric and magnetic force were thought to be independent. That is the Coulomb's law of charges. The force of attraction or repulsion between two electric charges is directly proportional to the product of their charges and inversely proportional to the square of distance between them. That law is called as the Coulomb's law in the electromagnetic force. This is the attractive or repulsive. Both forces are happens in that electromagnetic force. After the demonstrations of Faraday's and James Maxwell's, electric and magnetic forces were unified through the theory of electromagnetism. These forces are the stronger than the gravitational force. Majority of forces experienced in our daily life, such as the forces of friction, normal reaction, tension in the string, collision forces, elastic forces, viscosity, that is the fluid friction, etc., are the electromagnetic in nature. Under the action of these forces, there is a deformation of object that changes the intermolecular distance, thereby resulting into the reaction forces. These are the electromagnetic force, which is the attractive or repulsive, both are happens. That is the Coulomb's law of electromagnetic, Coulomb's law of charges, it happens in electromagnetic force. Next one, strong nuclear force. This is the strongest force that binds the nucleus together inside a nucleus. This strongest, it is a short range force. Therefore, a very strong attractive force and the charge is independent. Last one, weak nuclear force. This is the interaction between subatomic particles that is responsible for the radioactive decay of atoms, in particular beta emission. The weak nuclear force is not as weak as the gravitational force, but much weaker than the strong nuclear and electromagnetic forces. The range of weak nuclear force is small, and so that in order of 10 or minus 16 meters. This one is the weak nuclear force. See the examples of strong nuclear force, electromagnetic force, weak nuclear force, and gravitational force. These forces are the fundamental forces in nature. That is the types of forces, that is the fundamental forces in nature. This one, strong force binds the nucleus. Say electromagnetic force between the atoms. Weak nuclear force and radioactive decay, that is the beta emissions. And this one is the gravitational force binds the solar system. This one is the types of forces, fundamental types of forces. In summary, there are the fundamental forces: gravitational, electromagnetic, strong nuclear force, weak nuclear force. As the associate property, mass for the gravitational force, electromagnetic for the electric charge, strong for the color range, and weak for the weak charges. Effect: all the masses attract each other. In gravitational force, there is a no repulsive force. In electromagnetic force, opposite attracts like repulse. That is, there is a attractive or repulsive, both are happens. Opposite charges like attraction, like charges, that is repulsion. And strong, three colors combinations to make the neutral combinations. And massive particle decay or low mass particle, that is the beta emission in a weak nuclear force. Range infinite but weakness with distance. जसं distance वाढत जाईल तसं gravitational force हा कमी कमी होत जातो. It depends on distance, which is inversely proportional to the square of distance between the two masses. Infinite but weakness with the distance. This is again depends on the distance. As distance increases, electromagnetic force goes on decreases. Here the strong nuclear force is 10 raised to minus 15 meters distance between the protons in atomic nucleus. And here 10 raised to minus 18 meters, that is the proton diameter. See, carrier particles, gravitation, proton, gluon, W and Z, and this one is the relative strength. Here the fundamental forces in nature, again there is a strong electromagnetic force, weak interaction, strong interaction, and this one is the gravitation. This is the examples of fundamental forces in nature. In this way, in this lecture, we see that what are the types of motion. Summary of this lecture. First one, there are the these branches. Mechanics can be divided into two branches, statics and kinetics. Kinematics again two branches, kinematics and dynamics. Then this is the example of kinematics and dynamics. Then there are three types of motion: linear motion, circular motion, and parabolic motion. Next one, Newton's laws of motion. There are three laws of motion: first law, second law, third law. Then importance of Newton's first laws of motion, importance of Newton's second laws of motion, importance of Newton's third law of motion. Then what is the difference between inertial and non-inertial frame of reference? Inertial, in which the all Newton's laws is obeys, is called as the inertial frame of reference. Non-inertial frame of reference, in which the Newton's laws is not obeys. This is the difference distinguished between inertial frame and non-inertial frame of reference. This is the examples of initial and non-inertial frame of reference. And last point is that the types of forces. There are four types of forces in nature. First one, gravitational force. Second one, electromagnetic force. Third one, strong nuclear force. And last one, weak nuclear force. This is the examples of pictures of strong nuclear force, electromagnetic force, weak nuclear force, and gravitational force. This is the summary of fundamental forces.